Okay, so now we're going to do exercise 3, which we are asked to determine the general term of each of the following geometric sequence, right? So let's do number 1. Number 1, we are given a geometric sequence of 5, 10, and 20, right? And we are told that it's a geometric sequence. So the first thing we do is we identify the value of A, which is equal to 5, and our common ratio, right? So that's what defines a geometric sequence. Common ratio, how we're going to find it? If we say this is term number 1, this is term number 2, and this is term number 3, right? So common ratio is term number 2 over term number 1 equals to term number 3 over term number 2, which in this case is going to be 10 over 5 equals to 20 over 10, right? So my common ratio is going to be equal to 2, right? So, and then to find the general term, we know that Tn is equals to AR to the power n minus 1. So this is the general formula of a geometric sequence, and our A value is 5, our R is equals to 2. So just going to substitute that Tn is equals to 5 into 2 to the power of n minus 1. So you can leave it here or simplify it further. So I'm just going to leave it here. Then we're done with this problem here. So we're going to do another one, number 2, which we are given. So number 2, we are given 4 minus 12, 36. So we are told that this is a geometric sequence, right? So the first step is to identify the value of A, which is 4. It's our first term. R, which is equals to T2 over T1 is equals to T3 over T2. Remember that a geometric sequence is defined by common ratio, right? So if this is going to be our term number 1, and this is term number 2, and this is term number 3, so term number 2 is minus 12 over 4 equals to term number 3, which is 36 over minus 12. So our common ratio for this problem here is minus 3. If you punch your calculator, so Tn is equals to AR to the power n minus 1. So Tn is equals to our A value, which is 4, our R, which is minus 3 to the power of n minus 1. So this is going to be our general term for this problem here. And then now we're going to do number 3, which we are given as, okay, this is number 3, we are given minus 3, minus 6, minus 12, and you're told it's a geometric sequence. So our A value is equals to minus 3, and then our common ratio is equals to T2 over T1 equals to T3 over T2. T2, sorry, this is T1. It's going to be T1, T2, T3, right? So R is equals to minus 6 over minus 3 equals to minus 12 over minus 6. So R is equals to, our common ratio for this problem here is going to be minus 3, right? So our common ratio for this problem here is going to be 2, right? So we're having A being equals to minus 3, we're having R being equals to 2. So T subscript n is equals to AR to the power of n minus 1. T subscript n is equals to our A value, which is minus 3. Our R is 2 to the power of n minus 1. So this is going to be your general term for this sequence here. So now we're going to do number 4, which we have a sequence of minus 2, 10, minus 50, right? And we are told that this is a geometric sequence. So the value of A is equals to minus 2, it's our first term here, and a geometric sequence has a common ratio, which we define it as T2 over T1 is equals to T3 over T2. Term number 2 is 10, so it's 10 divided by minus 2, which is term number 1, is equals to minus 50 over 10. So it's 50, so R is equals to minus 5, right? So this is our common ratio. So to find the general term, we're going to use the general formula of a geometric sequence, and then T subscript n, our a is minus 2, our R is minus 5 to the power n minus 1. So this is going to be your general term of this sequence here. Okay, so now we're going to do number 5, which we are given 18, 6, and 2, right? And we are told that this is a geometric sequence. So we need to identify the general term. So our first term is equals to 18. Our R is equals to term number 2 divided by term number 1 equals to term number 3 divided by term number 2. So this is going to be, so let me just indicate a different color. This is going to be term number 1, this is going to be term number 2, and this is going to be term number 3, right? So my R is equals to term number 2 is 6 divided by term number 1, which is 18, equals to term number 3, which is 2 divided by 6. So my R is equals to 6 divided by 18 is going to give you 1 over 3. So let me write this properly. So it's going to be 1 over 3. So this is going to be my common ratio for this problem here. So to find the general term, we're just going to use our general formula of a geometric sequence. My A value is 18, right? And the common ratio is 1 over 3 to the power n minus 1. So this is the general term of this sequence here. Okay, so now we're going to do number 6, and the sequence is 20 minus 10 and 5, right? This is term number 1, term number 2, term number 3. And we are told that this is a geometric sequence, right? So the A value is equals to 20, common ratio is equals to term number 2 over term number 1 is equals to term number 3 over term number 2. Remember, we want to identify the general term. So term number 2 is minus 10 over 20 equals to term number 3 is 5 over minus 10. So R is equals to 5 divided by this is going to be negative 1 over 2, right? So that is our common ratio, and then Tn is equals to AR to the power of n minus 1. Our A value is 20, R is minus 1 over 2 to the power of n minus 1. So this is my general term of the sequence. So now we're going to do number 7. I'm sure now you understand how to find the general term of a geometric sequence. You can try out this problem here, which include fractions. I know we haven't done fractions, but it's an interesting way of just testing your skill, right? So now that you are more familiar, just pause the video and try out this problem here. and then resume the video to see if you got the answer correct. So we are told that this is a geometric sequence, and we are asked to find the general term. We know that A is equals to 1 over 2. We need to find R, which is T2 over T1 equals to T3 over T2, which T2 is 3 over 2 divided by 1 over 2 equals to 9 over 2 divided by 3 over 2. Right, so this is my R. So my common ratio for this problem here is going to be 3. So you're just going to punch your calculator the entire thing and see if you're going to get 3. And you also punch here and see if you're going to get 3. So then my general term is equals to AR to the power of n minus 1. And then my A value is 1 over 2. My R is 3 to the power of n minus 1. So this is going to be my general term of the sequence here. Okay, so now we're going to do number 8, which we are given the sequence of 2 over 3 minus 1 over 3, 1 over 6, right? And you're told that this is a geometric sequence. So my A value is 2 over 3, my R is equals to T2 over T1 is equals to T3 over T2, right? So my T2 is this one here, which is minus 1 over 3, divided by my T1, which is 2 over 3 equals to my T3, which is 1 over 6 divided by minus 1 over 3, which is my T2, right? So please punch this in your calculator and see what is the common ratio including this one here. So they must be equal to each other. So what I'm getting in my calculator is minus 1 over 2, right? Because this 3 is going to cancel out with this 3 when you divide, and then you remain with this 2, which will be replaced here, right? So it's just going to be minus 1 over 2 as my common ratio, and then now the general term is AR to the power of n minus 1. My A value is 2 over 3, so it's 2 over 3 into minus 1 over 2 to the power of n minus 1. So you can just leave it here or simplify it further. So that is how we solve these problems here. So we are done. Now we're going to do B, which we are told to consider the sequence as a geometric sequence. The first part of the question, you need to identify the general term of the sequence, which is something that we've been doing all along. So this is going to be 3, 6, 12, all the way up to 1, 5, 3, 6, right? And the first part of the question is to identify general term of the sequence. To find the general term, we need to identify the A value, which in this case is 3, and the R, which is T2 over T1 is equal to T3 over T2. So term number 2 is 6 divided by term number 1, which is 3, equals to term number 3, which is this one here, it's 12, divided by term number 2, which is 6, right? So my common ratio for this problem here is 2. So the general term is equals to AR to the power of n minus 1. So Tn is equals to my A value, which is 3, and then 2 to the power of n minus 1. So this is going to be my general term for this problem here. So just to write down the final answer for the first part of the question. So it's Tn equals to 3 into 2 to the power of n minus 1. So now I'm going to do the second part of the question, which says that we must calculate the value of the sixth term. So T6 equals 2, so we're going to substitute in this equation here. So it's going to be 3 into 2 to the power of 6 minus 1. So just punch this in your calculator, and what you're going to get is 96. Please confirm that in the comments. And in the third part of the question is you are asked to find a term that equates to a sequence of 3, 8, 4, right? So what this means is you have in your formula general term as 3 into 2 to the power of n minus 1, and you are given that t of n is equal to 384. So what is n, right? So you're going to say 384, substitute it here, equals to 3 into 2 to the power of n minus 1, and then now we're going to divide by 3 both sides. So it's 384 over 3 equals to 2 to the power of n minus 1, right? And then you're going to get 128 here equals to 2 to the power of n minus 1. So you need to simplify this expression here to be specific. So you're going to say 128 equals to 2 expanded 2. So if you know your laws of exponents, this shouldn't be difficult. And then you just divide by 2 to the power of minus 1, 2 to the power of minus 1. So 2 to the power of n is going to be equals to 256, right? So it's 256. So now we need the value of n. We need to identify n, right? So to find n, we need to make this 256 the same base as this 2. So it's going to be 2 to the power of n is equal. So you will test your calculator. Just punch 2 to the power of 3, 2 to the power of 4, up until you get 256, right? So that's how you're going to get it. So what I got in my calculator is 2 to the power of 8, and found that it's actually equals to 256, right? And then now you have the same basis, you just equate the exponents. So n is equals to 8 in this problem here. So we are done. So n is equals to 8. Now let's do the fourth part of the question, which says that how many terms are there in the sequence? So we are given this entire sequence and you're asked to find the number of terms. So to find the number of terms, you have to write first the general term, which is 3 into 2 to the power of n minus 1. So to find the number of terms of the entire sequence, we know that the last term is equals to 1536, so meaning that Tn is equals to 1536. So we're going to find n now. So it's 1536, substitute it here, equals to 3 into 2 to the power of n minus 1, divide by 3 both sides. We have 1536 over 3 is equals to 2 into n minus 1. And then you punch this into your calculator and you should get something like 512 equals to 2 to the power of n minus 1, so brackets. Then you expand this part here, so it's 512 equals to 2 to the power of n multiplied by 2 to the power of minus 1. Divide by 2 to the power of minus 1 both sides, and then you should get something like so 512 over 2 to the power of minus 1, it's 1024 equals to 2 to the power of n. And then because you're having a base of 2 to the power of n, you want to identify n, so you need to make this the base of 2. Just make base to the power of here you can try to punch in different numbers, 2 to the power of 3, 2 to the power of 4, up until you get this answer here, right, of which I found it to be 2 to the power of 10, which is equal to 2 to the power of n. So same basis, you drop exponents, so n is equal to 10. So that is my final answer for this problem here. We are done. Okay, so now we're going to do C, where we are asked to consider the sequence as being a geometric sequence, and the first part of the question is to determine the general term of the sequence. So we've been doing similar question, and the previous question that we did is similar to this one. So I'd advise that you pause the video and you try to attempt this question, the entire problems, actually attempt all of them and see if you're going to get the same answer. So that's how you will be able to tell whether you understood or not. So if you didn't understand, you are more than free to ask me the questions in the comment section below. So now see, we're having a geometric sequence of 2 over 9 minus 2 over 3 and 2, so it goes up to 1062,882. Right, so the first part of the question is to find the general term of the sequence, of which we now familiar with this. We know that the a value is equal to 2 over 9, and then the common ratio, since this is a geometric sequence, so it's t2 over t1 is equal to t3 over t2, which our r is equal to t2, which is minus 2 over 3, divided by t1, which is 2 over 9, equals to t3, which is 2, divided by t2, which is minus 2 over 3, right? So my common ratio for this problem here is minus 3, right? So the general term is equals to ar to the power of n minus 1. My value of a is 2 over 9, and then my r is minus 3 to the power of n minus 1. So this is going to be my general term for this problem here. So to write it properly, Tn is equal to 2 over 9 into minus 3. So now we're going to do the second part of the question, where we're asked to find the value of the 10th term. T10 is equal to 2 over 9, we're using this general term, into minus 3 to the power of 10 minus 1. So T10, if you punch your calculator, you should get minus 4374 as your final answer. And then the third part of the question, we are asked to find the term number if the sequence is equals to minus 486, right? So if Tn is equals to minus 486, what is n? Right, so what you're going to do is this: you're going to use your formula, right, which is this one actually. So Tn is equals to 2 over 9 into minus 3 to the power of n minus 1. My Tn is minus 486 equals 2 over 9 into minus 3 to the power of n minus 1. And then I'm just going to divide with this one here, so it's minus 486 divided by 2 over 9 equals to minus 3 to the power of n minus 1. And then you're going to divide this, right, and find its answer to be minus 2187 equals to minus 3 to the power of n minus 1. So we're going to expand this here, which is minus 2187 equals to minus 3 to the power of n multiplied by minus 3 to the power of minus 1. Then you divide by minus 3 to the power of minus 1, divide by minus 3 to the power of minus 1, and then this is what you need to get. So the answer here is going to be minus 6561 equals to minus 3 to the power of n. So we're having a base of minus 3, right, to the power of n. We need to change this base to be minus 3 also, right? So you can do that. You can just say minus 3, and then in the power you just put in, you test in any power. You test in from 3, 4, 5, or you can start wherever. But just make sure that the answer that you're going to get must give you minus 6, 5, 6, 1. So the power that I got is 8. So you're going to have minus 3 to the power of 8 minus 3 to the power of n. Same base, drop exponents, so n is equals to 8. Then you're done with this part of the question. So now we know that n is equals to 8. So now let's go down to the fourth part of the question. We are asked to find the term of the sequence, right? We know that the sequence ends at this value. So that's going to be our Tn. So we say Tn is equals to 2 over 9 into minus 3 to the power of n minus 1. And then Tn is equals to this, which is 106. So it's 1062882 equals to 2 over 9 into minus 3 to the power of n minus 1. Divide by 2 over 9. Divide by 2 over 9. And then the value that you're going to get, so you can punch this in your calculator. You're going to get 4782969. So I didn't just use my head but my calculator, so please use a calculator. Okay, so now we're having this here, so you can just simplify this part here. So you're just gonna have 4782969 is equals to minus 3 to the power of n multiplied by minus 3 to the power of minus 1, right? So you can divide by minus 3 to the power of minus 1, divide by minus 3 to the power of minus 1. And then this is what you're going to get. So the answer for this part of the equation is minus 1438,907 equals to minus 3 to the power of n. So now that you have this huge number and you're having a base of 3, so make sure that you also change this into a base of 3. So this is 7, by the way. So once you do that, and then you put a power such that when you say 3 to the power of whatever, it must give you this answer. Got it? So I got 3 to the power of 15 equals to minus 3 to the power of n. So therefore, n is equals to 15. So that is my final answer for this problem here.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.